There's another type of growth and decay function that we can look at, and it's this formula right here, y equals PE raised to the RT. It's still an exponential function, but this one is called an instantaneous or continuous growth or decay function, and the R is an instantaneous or continuous growth rate. If it's positive, if it's negative, then it's an exponential decay function, and then that's the decay rate. So for our example here, and the next few examples, we're going to be talking about money, and so our money is going to be growing. So our R value is a rate, the percent changed to a decimal, and it's going to be positive. We're going to be plugging into this formula where P is our initial amount, E is the amount on the calculator, that's a number, irrational number. The rate, we'll change the percent to a decimal and plug it right in. We don't have to worry about adding one or taking it away from one like we do with this formula here when we're looking at growth factor or decay factor. And then just simplify it. So for this problem, how long will it take? That's the T that we're looking for $15,000. So that's our P, to grow to $100,000. So that's the output that we want is 100,000 equals 15,000 E. The rate, move the decimal over 2 places to the right, 0.085 T. And now solve the exponential for T. So again, we need to get the exponent by itself, get rid of the 15,000 by dividing. And then once again, when you do this division, if it's not coming up a nice round perfect number, hold the digits on your calculator. And in this case, you'll see that, I'll put it up here, 100,000 divided by 15,000 comes up a bunch of sixes across the screen. In fact, my calculator is just going to round the last decimal place there, but it's really a bunch of sixes all the way across. I'm just going to hold that number, but what I'm going to write down is 6.66 with a bar above it to show that that was repeating. 0.085 T. It's an exponent, so I need a log to solve it out. Log base E of the 6.66 with a bar above it. So I'm not just stopping at 6.66. I'm actually going to type it all into my calculator. Equals the power. And then solve for T. So divide both sides by 0.085 because it's hooked by multiplication here. And I'm going to clean it up a little bit because another name for log base E was natural log of the 6.66 repeating divided by 0.085. All right, now go to your calculator, and here's a kind of a quick thing to do. Natural log of, now you could type in 6 point and then run sixes all the way across, or you just want the answer from above. So if I do second and then the negate key, it's going to put the word answer there. So it's going to take that answer and kind of do a cut and paste. Some of the newer calculators will actually show you what they pasted in there. Natural log of the answer divided by 0.085. And it comes up 22.3 because we want it to the nearest tenth of a year, so 1 decimal place. So 22.3 years. So when we see that word continuous or instantaneous, I know that I have to use this formula. That's your clue. So in this next one, I see compounded continuously. So I'm back to the PERT formula. Y equals PE to the RT. I start with 30,000 and I want to double it. So my input was 30,000. I want to double that amount out, so that's going to be 60,000. And the rate, again, is the percent changed to a decimal, and that's it. We don't change it to a factor. This is just going to be 0.0225. Move the decimal over 2 places to the left. And then solve for t. So again, get the e to the power by itself. And because we doubled it, when I do that division, it's going to simplify to the number 2. So if I'd have tripled it, then I'd be getting a number 3 here. E to the 0.0225. Get rid of an exponent by taking the word log base e. Now, some of you are going to get to the point where it's like, okay, it's log base e, so I'm just going to write in natural log, and you can do that, of 2 equals the power. So I have natural log of 2 equals 0.0225t, and then solve for t. Again, they want you to round to the nearest tenth, so type that into your calculator, and to the nearest tenth, it's going to come out to about 30.8 years. Notice when we're talking banking problems, our unit label is years. Right. Suppose $8,000 is invested into an account, compounded continuously, so we're back to the PERT formula, and the principal P that we're investing is $8,000. E, what interest rate, so we're looking for R this time, will it grow to $11,466.64 in 6 years? So when I plug in the number 6, this number comes out, but I need to know the rate. So once again, e to that power has got to be isolated. Divide by 8,000. So I have e to the 6 times r, or r6, either way, equals, and then when you do this division, it does come out a terminating decimal, so 1.43333. Don't round. All right, you round and you'll be surprised at how much you're going to be off in your final answer. Rewrite it because it's an exponent, so use the word log base e of 3333 equals the power, but we know log base e is really natural log. And then to get the r by itself, we're going to have to divide both sides by 6. So when you do that, r comes up as a decimal 0.06 with a bunch of zeros after it and everything. But to round to the nearest percent, I move the decimal over 2 places to the right, and it's going to round to 6%.